So if these are the key things that are in all of your formulas, N is the subscript number, U sub 1 is the starting term, D is the difference, R is the ratio, then if I give you this one, 10, 15, 20, ... I hope you know that the common difference is subtract. You take 15 minus the 10 and you get 5. It's going up 5 each time. And here's the formula we'd use for this one. U sub n is equal to U sub 1 plus n minus 1 times d. Let's figure out U sub 10 then. 10th term. U sub 1 is the starting term, which was 10, plus n, which is, remember, n is the subscript. So n is 10. So if I want 10 minus 1, I'll just write 10 minus 1. If I weren't showing you, I would have just done 9 in my head. And then times it by the common difference, which is this. It's the 5. So it's 10 plus 9 times 5. So 45 plus 10 is 55. 55 is U sub 10. Raise your hand if you understood that. Okay, good. Then what's the sum of the first 10 terms? All right, I want to tell a little story on this one. So it'd be like this. It starts with 10, and it goes up, right? And it ends with 55, is the biggest term. There was a super bright math student back in the day. It was back in the days when it was like a one-room schoolhouse for the whole area. And he was the brightest little kid in the room. And there were other kids of varying intelligence in the room, but they were in different grades. He was the little kid. And the teacher said, hey, Friedrich, which was what his name was, I would like you to add up the numbers from 1 to 100. And Friedrich didn't just go, boom, the answer's this. He wasn't like a genius that way, but he was an amazing mathematician. And he thought, I bet there's a pattern if I wanted to add up the numbers from 1 to 100. And he thought, well, 1, 2, 3. There's no pattern that seems to work when you just add them together. 1 plus 2 is 3, but then, and then the next one's 4. So it's not going to like keep going where 1 plus 2 makes the next number. So there's patterns, of course, but there was nothing working until he figured out at the end of the numbers was 100. And the number right before that was 99. And he came back up with the teacher after just like 2 minutes and he said, it's 5,050. And the teacher was like, no. I actually want you to add them all up. And he said, I did. And the answer is 5,050. And that's probably the first moment where the teachers started to realize, holy crap, this kid's a genius. Like Einstein level genius. Except his gift was in math. All right, so here's what he did. What's 1 plus 100? 101. What's 99 plus 2? Catch what I'm doing here? Add it up to 100 again. Do you get it has to keep on adding up to 100? If I take 98 plus the 3, guess what that adds up to? Keeps adding up to 101. And then he went, okay, so if it all is going to add up to 101, I just keep doing that, but how many times do I do that? Do you do it 100 times? No, you do it 50 times. And that ends up being 5,050. So what's the key? You take the beginning number, U sub 1, and the end number, which we can find using the formula we just used a second ago, that formula. And you take the beginning and the end, and you add them together. And then you take, remember how we times it by 50? We didn't times it by 100. We take half the number of terms. N is the number of terms, and so the formula always has this n over 2 in the front. If you ever wonder why it has that, it's because of Friedrich. He figured this out. You take half the number of terms you had. If you had 100 terms, you're going to add them all up. Add the first one, add the last one. And take half of how many terms there are. And take the first one. plus the last one, but the last term is the most complicated thing. The last term is going to be u, that's from this, that's the formula for the last term, okay, which is the starting term. So that's u sub 1 plus, and I didn't leave myself enough room. And I'm just trying to show you where this formula came from in case you're curious about this smart little German kid, Friedrich. And then this was n minus 1 times d. And when you put this all together, would you agree that u sub 1 plus u sub 1 is 2 times u sub 1? And that's what this formula says. This is one of those moments where I took a moment just to show you math history. That guy, Friedrich Gauss, Gauss became one of the most famous mathematicians of all time, and they figured it out when he was like 5, and he went to school and was able to add up the numbers from 1 to 100 with this method. Add up the first one, add up the last one. Keep doing that, you get the same pattern. By the way, that pattern even works for, like, let's say I want to take the numbers from 200 to 400, and I want to add them up. All of them, 200, 201, 202, dot, 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 all the way to 400. Let's see if you can be close to as smart as little Friedrich. What would these add up to? First one and the last one. 600. What do you think these would add up to? 600. Keeps on adding up to 600, doesn't it? How many numbers are there between 200 and 400? There's 200 numbers in there. So we take half of that, which is 100 combos of 600 each. So the numbers from 200 to 400, using this technique, there's n divided by 2, which is 100. And then this is our first plus our last. 600 times 100. And 6 times 1 is 6, and then we add 1, 2, 3, 4 zeros. 60,000 is what that adds up to. Okay, enough math history. So what's the actual formula? It starts with u sub, it starts with 2 u sub 1s. And it's also got that n over 2. Alexis, did you find it in the list? Can you tell me the rest of the formula? And you may remember that this used to be u sub 1, the first number, plus another u sub 1 for this number that goes down there. And this was the last number, and this was the first number. But they put the 2 u sub 1s together into a 2 u sub 1. Okay. So now let's actually use this formula to add up a bunch of numbers. And I think I challenged, I don't think I gave you the numbers to add up, so I'll tell you that part now. Let's say we start with 20, and we're just having a common difference of 2. So it would be 22, 24, 26. So like it's the even numbers. What would the first, let's make it 30 numbers add up to? Use this formula. You should know what n is. I told you in the problem. You should know what u sub 1 is. I told you in the problem. N comes up again. So if you don't know n, you're really doubly toast because it comes up twice in the formula. And last but not least is the d, which is the common difference, which you can tell by looking at the sequence. All right. Let's see what that adds up to. The first 30 numbers would add up to Eddie, how do I start this? You weren't paying attention, were you? Okay. Then you got to fight through it with me. I'll help you. The first 30 numbers add up to, so then n is 30. So then this is 30 over 2. If n is 30, I bet you can figure out u sub 1. You're that smart, aren't you? Know what you know u sub 1 is? Come on, u sub 1's the first number.
Oh, 15.
Look at the list of numbers. What's the first number?
Oh, 20.
20. Okay, so then I'm going to go 2 times 20 plus, do you have any short-term memory? What's n? Because I got to use n again.
30.
Mm-hmm. Minus 1 all times d. And what's the d in this problem? Mr. Tyler, what's the common difference in this problem? The d.
Plus 2.
Oh, there's 2 Tylers you got out of that one. All right. So this times 2 right there is times just that. And that's a bit of a pain. 30 minus 1 is 29. 29 times 2 and 2 times 20. And you might be like, wouldn't we have a calculator? Yes, you would. I'll be your calculator here. What's 30 divided by 2? 15. 2 times 20? 40. 30 minus 1? 29. Times 2. We're getting close. 15 times 29 times 2 is almost 30 times 2. But that doesn't really work. I'd say it's 20 times 2 is 40. 9 times 2 is 18. 58. It was almost 60, right? And then 15 times 98. Oh, pain in the butt. What I'd do is change 98 to 100, but then take away 2 from it. Watch what happens. This is just showing you how to do mental math fast in your head. Because 100 minus 2 is 98. 15 times 100 I can do in my head. 1500 is almost it. But then I got to take away 2 15s. That's like 30. So take away 30. And then the final answer, 1,470. Did anybody beat me to it? Raise your hand if you had 1470. Okay, cool. All right, so what are these formulas? These are formulas for series and sequences. And you aren't expected to memorize them, but you are expected to be able to find them. They're in yesterday's homework, and I bet you anything they're on the notes for today somewhere too. All right. Back to the simple stuff. U sub 1 equals... Parker, what's U sub 1 here?
75.
Good. Sage, what always comes next? U sub n. And this, yep. And then we got to say what happens. What do? Do we add 6 each time? Do we like times by 1/2 each time? It's divide by 5. But you can't say divide by 5. Well, that's a problem. Do you guys know what to change that to? If you can't say divide by, you got to say times. Do we just times by 5? No. Stella, what do you think? Instead of divide by 5, we could times by... Nope, 1/5. Instead of dividing by 5, you could times by 1/5. Does the same thing. All right. There's a formula. JP, what's that thing you have to add in, otherwise you lose 5%? N is...
Greater than or equal to 2?
2, yes, it's always 1 bigger than this. So, good job. That's it. There's the formula for that. Now, remember, some of you are like, I don't know how you got that times 1/5. Look, common ratio, 15 over 75. If I simplify that down, it's 1/5. 3 divided by 15. Simplify it down, it's 1/5. So the common ratio, it's 1/5. That's how I got that. Okay? That's why we times by 1/5 right there. Okay. Sorry about that, went too far. The goal for today is being able to make these sequences, which we've practicing since the first day. Calculate specific terms, and that's going to require those formulas. They got to give them to you, otherwise you'd be toast. And partial and infinite sums. That's where you have like 2, 4, 6, 8, ... And they say, what do the first 10 terms add up to? Grab the right formula and use it. Okay. Oh. What is this one doing that none of ours ever did before? Did they tell us what to start with? Yes. What got weird is it's 5 and then what's the next term? Well, it's not just like subtract 1. You know what's going on? Want to know what's happening? Well, what do you think we should do to the 5? Come on, you can do this. Do you think subtract 1 is involved? Yeah. What do you think that 2 means then? Two times the term in front of it. Remember, this is any random term. And this is the term before it. So you take the term before it, and you times it by 2, and then you subtract 1. You got to do both? Yep. You times by 2 and subtract 1. So let's take 5, times it by 2, and then subtract 1. Again, it's 2 times this number, and then subtract 1. That's what they're saying, because that's the u sub n minus 1. Because this is like u sub n right here. And this is like u sub n minus 1, 1 right in front of it. And so I take 2 times this, 2 times this, which is 10, minus 1 is 9, so it's 9. If I wanted to get to the next one, I don't just subtract 1. I don't just times by 2. I do both. 9 times 2, 18, minus 1, 17. Did anybody have 17 before I said it? Okay, cool. All right. That's the only thing that I think gets harder today, is you sometimes don't just add 2, add 2, add 2. You go like, I'm going to times by 2 and add 6 each time. All right. The 15th term, I'm going to give you the formula for it. U sub n is u sub 1 plus n minus 1 times d. There's your formula. Use that and get your answer. Noah, give this one a shot. I'll pause for a second. Okay, so let's start. U sub n is, in this case, u sub 15. And that means the 15th term. We're not adding things up. I just want to know what's the 15th term. And you start with u sub 1, which is 4, plus, and then don't tell me the final answer yet. Just tell me what's in between. What's this n minus 1 thing saying?
That's the number in the sequence you want. So
Okay.
you get 14 for that.
Okay, sorry, 15 minus 1, which is 14. Yep. So, yep, that's 14. And then how about the d, the common difference?
9.
So they were adding 9 each time. So it's 14 times 9, and no shame in using the calculator on that. And then you got,
139.
did anybody else get 139? Oh, nobody else has that. Oh, one other person has it. I'm going to double check you. This, 36 and 90, 126. Oh, I'm afraid you did it on your calculator too quick. Let me check this for sure. 90, 9 times 10 is 90, plus 9 times 4 is 36. It's 126. And then you got to add this 4. makes 130.
Yeah, I got 130 now.
Oh.
Back.
I thought you said 139.
Yeah, I think I might,
It's 130.
I think I might accidentally press 15.
Oh, that would do it. Instead of 14, that would totally do it.
Yeah.
Okay. Okay, so 126 plus the 4 makes 130. You use that formula effectively, you get the answer. All right, there's a list here of all the formulas, as you would hope, right before you're about to take the homework quiz that we're about to take, which is basically just doing the homework in my presence. And I strongly recommend right now, prepare for action. You ready? Take a screenshot of this. That's got all your formulas and a little hint of how to use them. And it's all organized really nice. It's way better than the other one yesterday. So screenshot that. Use the 2 buttons on your iPad. Get a screenshot. Why? Aren't you just going to give them to us? Not on every worksheet we ever do. So you got to be able to screenshot it so you can go back to it and go, oh, it's in my photos. I'm guessing you don't take lots of pictures on your iPad, right? So there's probably very few photos, so it's easy to find, and you'll be able to use that when you need it in class. Like, what's that arithmetic formula for finding the term? Oh, there it is. How about that formula for finding a term when it's geometric, like you're multiplying each time? That's this one. For series, where that's you're adding a group of them, remember series is different than sequence. Sequence is just like terms. Series is where you add the terms. Then you need 2 formulas for that, this and this. And for infinite series, you need these 2 formulas. That's 6 formulas to you and I. Well, some of them are copies. See, that was just that, and that's just that. So there's back to 4 formulas. Okay? What are the things in the formulas? N's, subscript. U sub 1, first number. D, common difference. N, subscript number. R, common ratio. Yes?
What's U sub 0?
U sub 0 is if you're doing a real world formula that is, so it's like it's like U sub 1, except if you're doing it with, instead of U sub 1, you can start with U sub 0? You can do that when you're doing a real world problem because you want to start at time 0. Let's say I was talking about throwing this stick across the room, okay? If I do that, it might lodge in somebody's skull and I'd probably get fired, so I won't do it. But imagine I threw this across the room and I start throwing it. I don't want to start at 1 second, or I'd miss the time between when I let go of my hand and it goes a ways, right, in the first second. So you want to start at 0 because otherwise you'd be missing the beginning of the experiment. Okay, so if they start with U sub 0, that happens on real world problems a lot of times where you have something happening between 0 and 1. Like if we're tracking your little baby brother and he's growing up. Well, you'd want to know what he was at the start, which is at time 0. You don't want to say at time 1. You want to start at time 0, the very beginning, and then after 1 year, how much bigger is he? Well, you need to know what U sub 0 was to compare with U sub 1. All right, so I think I explained that well enough. And the worksheet for today has somebody must have pulled it up by now. I'm going to come out and ask to see it so that I can tell which ones to skip. We'll just keep it simple. You're going to skip the last problem, do the other ones. If you get stuck, please come up and ask. And that's all I got for you for today.